Welcome everyone to the Solana Validator Educational Workshop. Today we're going to be talking about getting set up with FireDancer V0. So we've got Anway here from the FireDancer team, and he's going to walk us through uh, what FireDancer V0 is and getting set up with the code base. So Anway, go ahead and take it away. I'll let you share your screen.
Thanks, Tim. To start off, I can just briefly mention some information regarding FrankEndancer that probably most people are familiar with. FireDancer 0.1 or FrankEndancer is a Solana validator written in C with security, performance, and scalability in mind. Um, it is different from a full FireDancer as it still uses the Agave runtime and consensus. It uses its own implementation of TPU, signature verification, quick block packing, all the stuff that is active when a validator is the leader. And the Agave code lives in the repository as a submodule, as you can see over here. Whoa. Um, and this is actually pointed to a fork of the Solana repo, which will get updated to the Agave repo pretty soon. And this repo is updated in tandem with the releases that Agave publishes on their side. So if you look at the commit stack, you'll see that it is up to date with v1.18.17. And then on top of that, we have a whole bunch of FireDancer, FrankEndancer specific commits to make it work with the FireDancer code base. Um, so that is where the code lives. I want to talk a little bit about the release versioning because this means we need to track the Agave version as well as the FrankEndancer version. And that part is highlighted on the book that we have on our website. On the Git repository, if you scroll down here, it is this FireDancer docs link. If you go into the Get Started section and scroll down a bit, it mentions how our release numbers are structured. So we call this FireDancer v0.1 or FrankEndancer. For FrankEndancer, the major version will always stay 0. The first full FireDancer release will be a 1.x. The minor version starts at 100 and it increments by 1 for minor version patches and increasing the Agave code base, updating the Agave code base, and it increases by 100 for any major FrankEndancer specific releases. And then the patch version is actually an encoding of the version of the Agave code base that we run with. So if it is in line with v1.17.14, then it's 11714. So it's always going to be 5 digits. Um, yeah. So this page also has a whole bunch of information regarding running the validator. So please give this a read. It starts off with some specifics about hardware requirements. These remain pretty similar to typical Agave validator, the minimum and recommended requirements. Um, One thing to keep in mind is FrankEndancer uses a tile-based architecture where you can think of the whole validator as a collection of different processes that does their own thing. And each process gets its own CPU and a little bit of shared memory. And how we structure it is that the process uses up the entire CPU that it gets. So even we also run the Agave runtime and replay stages and everything alongside it. But during the replay stage, when it's validating blocks and the shreds that it's receiving, it cannot use the CPUs that we have dedicated to FrankEndancer. So the tuning and affinity and the core count is slightly more important. And we will talk a little bit more about this when we go through the configuration. Yeah. So I'm going to switch my share and actually start off a little bit of demonstration on running a FrankEndancer validator from scratch. So there, I have two shells open. So on the top one, I'll start by cloning the FireDancer repository. Um, you see, we add this recurse submodules flag to also clone the Solana submodule when we clone the whole thing. Without it, Git will actually not clone it, and you have to run a separate command. Um, we also update the FireDancer branch v0.1 to always stay up to date with the latest release that we have. So once it's done cloning, we are going to go into the directory and check out that v0.1 branch. So if you do a git log, you can see that the tag for our latest release, 108.118.17, is pointed to the head of this branch. It is always a good idea to run a git submodule update so to make sure that the submodule that you have cloned is up to date with what it should be. Um, and it looks like it is. There's some other steps also mentioned in the doc regarding installing Rust and compilers and make and etc. I'm not going to go through that. That's specific to the operating system, but we recommend using GCC compilers version 11, 12, and 13. We have a lot of testing that we do with that, so I'm just going to activate that. But you can compile with other different compilers as well. So the first step is to install some dependencies. There's a script called dep.sh that we have in the repository that does all of this for you. And it asks you to just continue, and this will go and clone any repositories, build any library dependencies that we have, install any packages, and all of that. Once it's done, it stores all of the stuff that it built in this opt folder. It's pretty self-contained, and you can always delete that folder and rebuild it to rebuild the dependencies and everything. So now that that's done, I'm going to kick off the build for the main binary that we're going to use, fdctl or FireDancer control. It's a combination, all the code that we need is compiled into this one binary. So you'll see it compiles a whole bunch of C code as well as a whole bunch of Rust code. And this will take a little bit of time. So in the meantime, I'm going to switch back my screen share again to talk a little bit about the configuration part. Okay, one more thing that is worth mentioning is that it's detailed in the getting started guide as well, that this automatically compiles for a native machine type. So it detects all the different types of architecture and properties your machine has, and it compiles the best possible binary for that. If you want to cross compile for a different machine, then you can specify the machine type like this and compile it there. If you go to the repository under the config folder, there's a machine subdirectory, and you can see all the different architectures that we already have there. And native is the default one, which, like I said, detects everything. Okay, the next part I want to talk about is configuration. And the default.toml is a great place to start. FireDancer takes its configuration from a TOML file. The default.toml serves as a file where all the default configuration values are stored, as well as a rich source of documentation for what all these configuration values do. There's a lot of stuff in here, so going through the whole thing will take a long time, but I highly recommend people to read it for anything they're trying to find. One common question that I feel like people might have is a flag or something that you used to pass to the Agave validator. How would you pass that to FrankenDancer? And the best way to go about it is come to this default.toml, try to find that flag over here. So let's say you used to specify the path to the ledger directory with -- ledger. So if you search for it, it'll show you the exact part in the TOML file and the thing that you set to specify the same thing to FrankenDancer. Or you want to store your snapshots in a separate directory than where your ledger is. That is also pretty similar. You used to pass the -- snapshots flag. Now you pass it. Now you specify that in the TOML file here. So there's plenty of options over here. We there's also a whole bunch of FireDancer specific options, and we will talk through some of them as we look at the configuration toml that we use to run on testnet. So I'm going to switch back my screen share again to the terminal because it has finished building our binary. And before we run it, I will briefly show you the toml file that we use. So one thing to note is the default.toml has all the default values that go into the configuration when we start up. And you can pass the fdctl binary another toml file that will only override the values you specify in the file. So whatever you don't specify stays the same. Whatever you do specify gets overridden. That way your configuration file is not massive like that default file. Yours is restricted to the set of values you care about. I would like to talk a little bit about some of these values. The user field in particular, we mentioned this in our documentation as well, that the user that I am running my commands as, you can see, is not the same as the user that I specify here. The Solana user, what we used to run our Solana validator with as well, is not a privileged user. It does not have super user privileges. And this is the user that FrankenDancer will drop all capabilities, switch its UID and GID, and run as finally. But that is not the user that is running the commands itself. The user running the commands itself needs the super user privileges. And we have the normal entry points, dynamic port range. One thing to note is RPC is off by default. So if you want to run queries against your validator, you need to turn that on. We try to monitor some things, so we have all of that turned on. There's some path to the log file, path to the ledger directory, the limit ledger size flag that I think is pretty common and a lot of people use, identity path, vote account path, options to fetch the snapshot in Genesis, known validators. Yeah, there are a few more options that I do want to talk a little bit more about, but I want to start the validator first because it's going to take a little bit of time for it to download the snapshot and come up. So while it does that, I can talk more about the FrankenDancer specific options a little bit more. So let's see. If you go and look into the book, all of this, everything that I'm talking about is also detailed out there. The first command that we need to run is a configure command. So use a fdctl binary, configure init all, and pass in the path to the toml file that you used. And you need sudo to run this command. This goes and configures the huge TLBFS. So it also prints out, the manual shell commands that you would run to have the same effect. It configures sysctl parameters, NIC channels, etc. One thing to note, this does it based on the config that you pass in. So it allocates the amount of memory that is necessary for this configuration of FrankenDancer to run. And once that is done, we run the run command, and which looks like this, which is the same as pretty similar. Make sure you pass in the same config to both of these commands. And then that's going to go ahead, turn a whole bunch of stuff out. You can see a whole lot of tiles that start up over here. It starts up the Solana PID, and that's the Agave validator side of things. And it seems like it is stuck, but it is not. What has actually happened is we've suppressed the amount of logs that are output here by quite a bit. It doesn't output the tremendous amounts of Solana metrics logs. These are configurable to a certain extent, but also the level of log output on the standard error is even less than the file. We'll talk a little bit more about logging soon, but before that, because I don't want to hog my whole terminal, I'm gonna stop this real quick. And I have this little systemd unit that I wrote that has exactly those two commands that I showed you, put it into a systemd file so that I can start it with systemd and stop it with systemd. And now it's simply a matter of um, running systemctl start. We can look at the standard error now with journalctl, like any other service. You can follow it to see that it shows something quite similar to what we were looking at a while ago. And there's a log file as well. And again, we'll talk a little bit more about logging, but you can tail that log file. I named it frankendancer.log, which also seems like it's kind of stuck doing nothing, but it is actually doing a lot of stuff. We will talk about that. Okay, to go back to the discussion about configuration so that we finish everything. One important thing I wanted to talk about is the layout. So this is pretty unique for FrankenDancer, and this needs to be tuned a little properly so that you can get the best possible performance out of your box. So we have two types of processes running. One is the FrankenDancer tiles, which is following the affinity rules specified here, and the other are the Solana Labs threads, which are following the affinity rules specified here. A couple of things to keep in mind is not all the tiles that are running are configurable in the TOML file. For example, pack, dedupe, these are tiles that run, but they can only be one of each, and you cannot configure the number in the number is not there in default.toml, the number is not there here, you can't change it. So to actually know which tiles are running, what you can do is you can run the fdctl mem command using the same binary. So let's see, and pass the configuration toml that you built to it. And you can see at the bottom, it prints out all the tiles that it's running. So here you can see the net tile, quick tile, dedupe, pack, how many verifies and everything. And you can see that there are 16 tiles that are running in total. These are all the FrankenDancer tiles. So that tells you now that when you write out your TOML configuration over here, you specify 16 tiles. We left core 0 for the operating system. And we give the rest of the cores on this box to the Solana Labs threads. And this is important because, like I said, these threads will not be able to get any CPU time from these cores. And we want to make sure that the replay stage has enough cores to actually catch up and verify blocks, verify the replay stage and all that. So we want to make sure that these two ranges do not overlap. There are some more options that are, there's plenty of other options. There are some more related to specific tiles. These are related to shred tile, quick tile, and I don't want to go into too many details about everything, but you can also report your metrics through this reporting block, and you can set this Solana metrics config variable to the same thing as you would have set the environment variable when you would run Agave to report your metrics to the Solana's influx database. Okay, cool. So I also wanted to talk a little bit about logging. So FireDancer or FrankenDancer have two places that they log things. One is the standard error, which I showed you with journalctl. And you can see that it has printed out some more things over here, like timeouts, but the log level for this is pretty low. It is, or pretty high. It is notice, and all the log levels are detailed out in the default.toml file, but the whole log file has more logs. So the entire log file, the file actually, I mean, has logs of the level info. So you can see more things being outputted here. And you can configure the log levels of both the standard error and the file in the default.toml or the config toml that you pass in. And the Solana logs, the Agave validator logs, they're all using FrankieDancer's login system as well. So those logs will also show up here. So you will likely see stuff from .rs files similar to the .c files over here. And again, like I mentioned, the Solana metrics logs are suppressed significantly, so you don't see too many of those. Okay, so to monitor the validator that you just started up, you can build the Solana binary, which I'm gonna kick off over here. That's gonna take a little bit of time. So while that builds, I want to show you another page from the book regarding monitoring. So I'll change my screen share for a second here. So we have a monitoring page here that tells you some basics about monitoring the Franken-Nestor validator that you just brought up. Make the Solana binary. It's available in the repository. It's from the FireDance repository itself. You can run very typical Solana gossip, catch-up, validators, typical commands that most people are familiar with, and you can grab for your pub key to see how it's doing, if it's delinquent, how many slots it's behind, how many blocks it has produced, how many blocks it has skipped, and things like that. There are also Prometheus compatible metrics that FireDancer publishes on port 7999. They can be ingested into any like Prometheus exporter, Prometheus node scraper, and there's a lot of metrics, and we can probably do a whole different talk on what they are and what they mean. There's also a FireDancer monitor, which is a better view into the world of tiles that I was talking about and everything that's running. And we will actually look at that to see how the output of that looks like and sort of understand a little bit more about what the output means. One thing to note is, although we don't provide the Agave validator or Solana validator binary from the FireDancer repository itself right now, if you still have the binary, then you can run similar commands as you would to monitor your validator. And I'll show you a couple of them just to monitor the state of your validator. So I think everything is built now, so we can go back and try running some of these commands that I was talking about. So if we run a Solana validators command using the binary that we just built, you can see that this is our validator that we are running. It is not delinquent anymore, so it's caught up, which we can verify with the catch-up command. And that takes a little bit, but you can see that it has caught up. If you have okay, let's talk a little bit about the Franken-Nestor monitor or the FireDancer monitor. So it's the same binary, fdctl monitor, and you pass in the config file that you started your validator with. Okay, it's a little jittery. I'll make this tiny bit smaller. Hopefully this is still viewable. So the top part, you can see all the tiles that are running. The stale column tells you if they're properly heart beating or not. The little green dash means they are. You can look at some of the other, there's a lot of information here. Not going to go through all of it, but some useful ones. The percent wait tells you the amount of time the tiles are waiting for data. Percent finish tells you the amount of time the tiles are actually doing a bunch of work. The links are basically the shared memory workspaces that the tiles use to communicate between each other. And you can see the total TPS column is a pretty good indicator to tell you which links are pretty active. You can see net to shred getting a bunch of traffic. These are the shreds that are coming in from testnet. Shred to net, because then the shred tile propagates those shreds out again. Shred to store, because you want to write them down to the block store. and a whole bunch of messages have been received. So the transaction sequence numbers are going up. We also have a little back pressure count here, which is zero is great. If the tiles are not back pressured, then means we're processing everything at a pretty good, pretty good rate. And yeah, um, I guess overrun count also shows you if we were unable to process some of the messages that we received because we were too slow. Yeah, so lots more information here, but
Can I ask a question about this view?
yeah.
Yeah, I'm curious. Let's say I configured my layout and I'm having trouble keeping up with the cluster with the layout that I've configured. What would be some good indicators here to sort of take back to the layout section to fix?
Um, if I think one thing that I remember seeing is when we had one shred tile, the amount of test and traffic was significantly high, and you would see the shred tile either getting back pressured because either this writing to the store is not fast enough, or sending all the shreds out to the thousands of other testnet validators because you have to compute the destinations for all the shreds. That is not fast enough, and you would see a significantly high amount of time where it's stuck at like 99%. So if you see a tile really stuck at 99%, it's never going down, then it's probably a good indicator that maybe we need another one of those tiles. Um, or if you, yeah, so that would probably go hand in hand with the wait percent being almost close to zero. So that would be a good indicator.
Makes sense. Thanks.
Right. Okay, so I guess one other thing is if you had the Agave validator or Solana validator binary, you can also pass in the path to the ledger because that is still compatible with the Agave validator. You can just run this and see the same information that, so I'm running the Solana validator monitor command, see the same information you would see for standard Agave validator. It also means that the ledgers are compatible, so you could potentially start up a Agave validator with the same ledger. One more command is the wait for restart window. So if you're trying to upgrade your validator, or if you're trying to get like a window of time where you want to stop it, let's say update some configuration parameters, add a tile, or you're trying to upgrade and use the next version, next release binary, you can use that Solana validator or Agave validator command as well with the wait for restart window command, give it like a, I don't know, 5 minute idle time, and it should tell you when the next idle slot is. So it's in 470 slots. You wait until that is done, and then you can do whatever maintenance work that you need to do. If you're running it with systemd unit, just something like sudo systemctl stop is good enough to stop the thing. It'll send it a kill signal, it'll die. If you're not running with systemd, you can do simple sudo pkill fdctl. That works too. Um, but either way, when you start back up, the important thing is to remember to run the init command and then the run command. So grouping that together is pretty useful. Yeah, that's pretty much all I had to say. Any more questions and stuff you want to ask?
Uh, no, I think that's awesome. Thank you for going over that, and I hope it's useful for all the operators out there. Thanks, Amway.
Yeah, thank you.